In this question, we are asked to use Coulomb's law to explain two phenomena. Now, it's important to note that when answering a question like this, because the question directly references Coulomb's law and states that you need to use it, the answer must directly reference Coulomb's law. If you don't reference Coulomb's law, you will get no points. Remember that Coulomb's law states that the force of attraction and repulsion between two charged points is directly related to the product of the charges and indirectly or inversely related to the distance between the charges. Here is the mathematical formula. Remember that F equals force. We are going to be looking at the magnitude because the sign will be negative. In dealing with simple atoms, Q1 is always -1, the charge in a single electron. Q2 will be the effective nuclear charge, which for all intents and purposes is the number of valence electrons. And D is the distance from the nucleus to the electron in question. So let's look at the first phenomenon where you're asked to explain why it is easier to remove a valence electron from a radium atom than from a calcium atom. Coulomb's law states that the force of attraction is directly related to the product of the charges. Both radium and calcium are in the same group, so they're the same effective nuclear charge. So that means the product of Q1 times Q2 is constant, so that's going to have no effect. We know that the force of attraction is inversely related to the distance. Radium has more energy levels, so the valence electrons in radium are further from the nucleus than the valence electrons in calcium. The further the distance, the less the force of attraction. The lower the force of attraction, the easier it is to remove an electron. So based on all of the above, it is easier to remove a valence electron from radium than from calcium. QED. QED stands for Quod erat demonstratum, Latin for thus it has been demonstrated. QED is stated at the end to show that the statement you started is the statement you end up with. So let's look at the second phenomenon, comparing the valence electron in chlorine to sodium. Quick review, Coulomb's law is going to have to come into play, and we know that the force of attraction between the nucleus and a valence electron is directly related to the effective nuclear force and indirectly related to distance. Chlorine has a higher effective nuclear force. It's in the same period as sodium, but it has more protons. So the product Q1 times Q2 has a larger magnitude, so the force is stronger. The stronger the force, the more difficult to remove the electron. Therefore, it will take more energy to remove the valence electron from a chlorine atom than from a sodium atom, QED. So utilizing Coulomb's law, we have explained both phenomena.